Thank you very much. Welcome, everyone. I am representing two entities now. One is Eötvös University, our research base, and the other one is Colmot Robotics, our company founded for drone swarm goals. Eötvös University is the largest university in the beautiful city of Budapest, right next to the Danube. A fun fact is that we have a statue from a contemporary artist right in the garden in front of us, called the Monument to Nobel Laureates, thought as a spatial pass, that abstract thing in the bottom left corner. We always think about this as a toilet bowling the drone trajectory, so we recreated that with a real drone in the middle. Colmot Robotics is started as a spin-off company like 10 years ago. Our overall goal is to have intelligent drone swarms all around the world, functioning as something that society benefits of. It was founded purely by researchers at the university 10 years ago. We do mainly software development and some hardware. We have a strong research background due to the university, but we operate commercially. Most of the income is coming from software licenses from Skybrush, what I will introduce to you. We do our share with drone shows, some precision agriculture, dual use, and big R&D projects. And we operate an open core business model, which includes using ArduPilot as well, for which we are very thankful. We don't have investors, have organic growth, and all the joy and excitement of open source. The name of Colmot Robotics comes from collective motion, because at the university, these are the very complex and beautiful systems, distributed and self-organized systems that we wanted to understand and model and replicate with drone swarms. And in my opinion, the main reason why in 2021 Giorgio Parisi received the Nobel Prize for understanding such systems and not my professor Tamás Vicek, because in Rome they had a much better experimental setup with a lot more Starlings than what we have in Budapest. But we also did our share with drone swarm research, starting with a microcopter system, if any of you remember that, back in 2011. And then in 2016, we changed to ArduPilot as our base autopilot. And over the years, we increased the swarm size and have now a system in which we can operate even 100 drones autonomously in a fully self-organized manner, doing all kinds of stuff. Some videos showing how these systems look like. We basically have two different operation modes for these large-scale swarming systems. One is replicating the motion of birds, which is kind of a flocking behavior. You see these drones moving around. It's a real video. These are only communicating between each other via an ad hoc Wi-Fi network, so a ground station is not even needed, and they synchronize their motion based on the information they receive from the vicinity. And the other mode of working or cooperation and coordination is kind of a traffic situation when the drones don't have a common goal to synchronize. They have individual routes, but they have to find out how to avoid collisions in a very densely packed situation. And we demonstrated with 100 drones that this is in fact possible with our algorithms and our software and hardware stack. And in simulation, we could obviously go larger than with real drones because it's kind of cheaper. So this is the same algorithm working on 5,000 simulated drones doing self-organized, coordinated motion. Compared to that, one human operator who is doing the air traffic management can handle maybe around 7 to 10 maximum units in one area. So this is a very efficient method, and hopefully in the long term, some kind of automated method will replace the current air traffic management systems. So Drone fleet we are operating since 2016 based on ArduPilot looks after 10 years it already looks historical because the drone world is changing so much, but we managed to build up a drone system which works still after 10 years. The hardware setup is something like that. We have an autopilot from the original Pixhawk family, some kind of an onboard computer. We usually don't use Raspberries, but Odroids, but they are very similar. We can have now later better chips. Typically a Wi-Fi system and a secondary radio system, and for ground truthing and for precise applications, we always use RTK-based GPS, GNSS. And on the software stack, we, as the low-level flight controller, we use ArduCopter plus modeling protocol. We have our own high-level swarming algorithms running on this onboard computer, which we call Flock Control. It's a closed-source system, but based on the open research that we publish usually. And the ground station is running the Skybrush software I will talk about. It's open core. Basically, people are using it for drone show projects, but it has some kind of a mission mode in which you can operate a lot of in many applications. And we use a long list of programming languages for all this stack. The full stack of software looks like this. We also have like a full software in the loop simulation framework, which runs exactly the same software as the real drones. So it's very handy when you operate 100 drones. You have to have all different levels of simulation because it's very costly to do experiments and to do crashes and. In the early times, it could happen that we were testing the algorithms right on the field without a simulation, and like you just change a switch and then 20 drones fall down that you were working on for 2 months. This is really bad. So you need a simulator. We can connect to obviously any kind of basic flight simulator, AirSim or Gazebo or whatever else. We have an open source component. AP ArduPilot Swarm Launcher, which is written by Tomasz Nepus. It's on GitHub. This organizes this whole setup where not a single one, but multiple ArduCopter instances are executed, one for each drone, as many drones as you want. It can run basically even several hundreds easily. And on the drones, if you want to simulate this swarming behavior, you can have this flock control running on each drone, and then you get the communication between the drones as well easily. Or you can have our other software stack, which handles the visual object recognition of drones, and then you have some kind of vision in the drones, and then all the drone communication is channeled into Skybrush server, the backend component of our open source ground control station. That has like different extensions for different drones. So if you have heterogeneous drone types, you can even communicate through Skybrush server and look at the drones as a drone entity, and you don't have to care about all the different aspects of individual drones. And then there is a front end called Skybrush Live, in which you can operate the missions, monitor the drones, and it's highly optimized for multi-UAV usage. It's a fully open source component, the front end. This whole Skybrush ecosystem on the ground is open core. We use open source firmwares. Outdoor, we use the ArduCopter. Indoors, we use the Crazyfly system. Both of them are very nice autopilot systems. We have the open core GCS components, Skybrush Server and Skybrush Live. We defined these standard, for us, these standard protocols between server and live, Flockwave and Sun formats that define these multi-drone mission and drone show types that are also available and well documented. We try to have very high quality code and transparent documentation, which is available online, and we have a Discord server on which we have already like 2,000 users in 3 years. So it's really going well, and nice discussion is going on there. And not open part is that we have this swarm level control on the drones. We can have project level extensions for the server that are closed and it extend the capabilities of the server. And of course, we do custom solutions for custom applications. The whole Skybrush ecosystem is open source since 2022, and we really enjoyed this decision to open this, and it's a very nice feeling to be in this open source community. Okay, what we do with Skybrush, one thing that we do is that we did our own share from the drone shows. One of our earliest drone shows was actually in the UK, in above Buckingham Palace Gardens, with a drone launch fireworks. Even it was a Christmas show for the royal family. That was the occasion where we got the permission in the shortest time, maybe like 3.5 minutes or so. And we did many shows all around Europe and even in China in the early days. And we have many users who use Skybrush, either the open source component, open source community version, or the enhanced professional versions for doing small and very large shows all around the world. But we use Skybrush in other modalities as well. So, for example, we have a cooperation with another Hungarian company with an actual product, a crop spraying drone that is running Skybrush and doing terrain following, crop spraying very efficiently. And it's really comparable to the big companies, the drones out on the market. And we have some R&D projects with Hungarian consortiums about like building up multi-drone and multi-UGV, like ground and air vehicle, like distributed surveillance for dual use. And this is kind of a short introduction how Skybrush Live looks like with a mission. You can have one extension for any kind of mission you want. You select the mission type you want to plan. You set up some input parameters, like how quickly the drone should go. You select the area and the drones and just create the mission automatically, then upload the mission to the drones. It's going very quickly. I cannot even keep up with the video. Then you switch all the drones. This is a demo for 5 drones to guided mode. That's where we operate through this companion computer. And then you can individually or as a group or as all of the drones, you can just start their motors and they will start. Individual drones status can be checked. So for example, here now 3 drones still have this pre-arm failure. So we will check what is going on, and the others start this kind of automated surveillance within this area that is there. You can communicate to individual drones, ask their status, and anything that you need. You can give individual or swarm level commands to the drones. Now all the drones are ready, so we start the rest of them. Everything is adaptive and real time. This is actually a simulator, so you have the air sim window there, seeing the drones, and anytime you can make the drones not follow the prescribed mission, but to fly them here and there, anywhere where you want. You bring them home alone or in a collective manner where they avoid each other. They can also avoid the obstacles in the area, even convex or concave. So we have written all this in this swarm level operation. And so it's a very adaptive and very flexible general framework where you can operate for the drones for any mission. And then you can like customize this whole very flexible framework for different applications. And one last thing after you land with all the drones, you usually need to check the logs for everything. And we have just released a very new tool for this. We have this Q&A style log analyzer. It's in a beta testing phase, and this is the first moment when I announced this that please go to this poplan.skybrush.io page and check it out. If you have some logs to analyze, it's optimized for like questions that arise over time again and again, and then you get like a quantitative answer to this. So it's very good, useful for tuning drones and for checking whether there are any warnings and errors that appear from the log file. Okay, thank you very much for your attention. We are very thankful for the Ardu pilot community, and we are here to cooperate. So if you're interested in swarming, then let's talk. Thank you very much.
Thank you for joining us for the Ardu Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.